Hello, I'm José Roberto Pegler and I'm pleased to have the opportunity to demonstrate how to obtain the T-wave alternance values from ambulatory ECG or Holter files using the MAR software from GE Healthcare. First of all, it's necessary to open the software and select the patient whose recording you intend to analyze. Then you should find the waveform measurements icon in the bottom of the screen and drag it to the lower window. Also drag the strip review icon to the window in the center. In the waveform measurement section, click on Setup and make sure that the only boxes that are checked are the TWA and the 15 seconds. At the Tools section, be sure that you have selected all channels in which you want to analyze TWA. Then just press Run, Start, and allow the computer algorithm to analyze the recording. It will take a few minutes. After the analysis is over, click on Stop, Close, and Save. And make sure that you are saving all channels. Now, the software has generated one Excel file with all TWA analysis results for that patient. It would be possible to get the T-wave alternance values using just tools from the software, but using the Excel file makes the overreading simpler, since you can check all channels simultaneously, while on the MARS you have to check channel by channel. Precordial leads are best for TWA analysis in most patients. Limb leads are known to contain large amounts of motion artifacts, and TWA in these leads should be interpreted with caution. When cardiomyopathy or channelopathy such as the long QT syndrome are suspected, which result in diffuse change in myocardial substrate, all 12 leads should be closely monitored. Some conditions, such as the long QT syndrome and drug-induced QT prolongation, may result in unusually long QT intervals. In these conditions, caution is advised to ensure that the templates encompass the entire JT window. Now, you need to find the Excel file that you generated. It's usually saved as the name of the patient, but in the .twa format. Open this file. You will have to use some formulas in this file, and you can find an example of Excel file with these formulas to be downloaded at the Wikidog page for TWA. I'm gonna use a model that is in my desktop. Go back to your file and add 4 rows to your spreadsheet. Go to the model and copy the formulas from C2 to Q2 and then until the end of the model. Paste these formulas in your file in the cell C2. Now you can see at the top right of your file that you have the maximum TWA for that period. You also have a column for values equal to or greater than 20 microvolts and a column for values equal to or greater than 40 microvolts. It's very important to make sure that the start time of our file corresponds to the real start time of the recording. Just check if the last zero that you find here in this column after the channel column so it will be this one. It matches your start time of 0 hours, 0 minutes and 15 seconds. In this case we are correct. It's also very helpful to freeze panes by going up clicking on the J5 cell, click on Window and Freeze Panes. Now you can save this file in your folder of preference. I'm gonna save in my desktop, but you have to save it in the XLS format, and you can also change its name. To start browsing through your file, just select a column with TWA values, press Ctrl and F at the same time. Be sure that you're looking for values and not for formulas, and type in the highest maximum TWA value that you have so far. You will see at what time that value was reported. In our case, it was at 15:42 minutes and 30 seconds. Now that you have the time in the recording for which the software reported that specific TWA value, let's go back to the MARS to overread it. Look for that time in the waveform measurement window. Remember, it was 15:42 minutes and 30 seconds on lead 1. You can press here on run, and you can go to 15 seconds before and 50 seconds later until you find it. So here we have our template and the tracings. As soon as you click on the waveform measurement window, the strip review window will automatically synchronize at the correct time. Note that when you are searching through the waveform measurement window to find the template for that time, the template is always in a 15 seconds interval before the one that you have in the Excel file. For example, here in the Excel, we have the time of 15 hours, 42 minutes and 30 seconds. And here in the Mars, we have the templates at 15, 42 and 15 seconds. It's in the beginning of the 15 seconds period. Now, with the template and the 15 seconds interval that precedes the time period that you have found on Excel, you can use the algorithm that Caio Tavares will show you to see if this is an appropriate TWA value or if you should discard it and continue with your search for the highest TWA value in the recording.
Hello, I am Caio Tavares and I'll guide you through the TWA tutorial in the MARS system. To begin, I will explain in detail the approach that is used for overreading of the Holter tape. I also want to take a brief pause here to thank Dr. TWA, who is responsible for designing this approach and for supporting us with technical and scientific knowledge. Here are the steps that we follow in analyzing TWA. This is the algorithm was designed for the analysis. It is pretty much self-explicative, but I'll explain it step by step. So, beginning with step number 1, check the template. If the template of superimposed bits looks odd or has a bizarre shape, such as when the QRS and P wave are not aligned, or the mean complex of odd and even bits are crossing multiple times, you should discard that value. Here are some examples of templates of superimposed bits that should be discarded. In this example, you can see the irregular appearance of the notched template. You should discard it right away. In this other example, you can see how awkward the template is. It also should be promptly discarded. So, going back to our MMA algorithm, let's move to step number 2. Check the EKG. We should discard EKG tracings with noise greater than 20 microvolts, baseline wonder, everything that could disturb measurement of TWA. Here's an example of how noise can affect TWA. If you pay attention to channel 2 here, you can see that this noise in the beginning of the JT segment can affect the measurement of TWA. That's why overreading is necessary for a precise measurement of two-wave alternates. So, going back again to our MMA algorithm, let's proceed to step number 3. You must check for atrial fibrillation, ventricular tachycardia, ventricular pacing, and QRS alternates. T-wave alternates cannot be accurately measured in such conditions, so discard TWA values generated under these conditions. Step number 4. Check for extra systoles. According to the guidelines, if there are more than 2 extra systoles in the 15-second period of that reported value, you should discard the TWA value. So make sure you count the extra systoles in the tracing you are analyzing. And finally, step number 5. If you have finished all of the previous steps and the value that you have is the highest, that is your peak TWA value for that patient. That completes the measurement process. So, continuing with José Roberto's example, we need to check the value 104 microvolts at channel 1 at 15 hours, 42 minutes and 30 seconds. Let's go to the march to do that. Let's overread it. Overreading the EKG, we promptly realize that there is noise in that tracing, so this value should definitely be discarded. We then need to return to the Excel file, delete the cell that has this value, and find the next highest TWA value. So let's do that. As apparent, the next highest TWA value is 65, so let's find it. So the next highest TWA value is at channel 3 at 13 hours, 05 minutes and 30 seconds, and the value is 65. Now let's overread the EKG for this value. You always need to change the channel in the TWA window to the channel the Excel file is reporting you, as I'm doing right now, changing to channel 3. So we need to check 13:05:30, so we need to find the template at 13:05:15. This template here, channel 3. Take a look at the tracing, we can see big humps in the JT segment. This is also considered noise, and this template and this value should be discarded. So let's go back to the Excel file and delete it. Restarting the process, we recognize that the next TWA value is 63. Let's find it. So the next highest value is 63 at 14 hours, 48 minutes and 45 seconds. Let's overread it at the Mars system, at channel 1. So we need to find the template at 14:48:30, channel 1. This tracing is very clean, the template is clear, there is little noise, no extra systoles or any other element that should make us discard this value according to our criteria. So we have found the TWA value for this case, and we have also reached the end of our session. Hopefully you have found this tutorial useful. We are pleased to have had your attention and to have had the opportunity to facilitate our implementation of TWA analysis with the GE healthcare system. Thank you very much.